Hi, and welcome to a demonstration of how to input meteorology data into Root Zone Water Quality Model. Root Zone Water Quality Model, or simply Root Zone, is software that allows users to simulate crop productivity, water movement through the soil profile, soil carbon and nitrogen cycling, plus runoff and tile drain volumes and contaminant loads. Together with site management and soil profile information, inputting or creating meteorology data is a key step in parameterizing the model before it can be run. The model needs weather data on at least a daily resolution, but it can use hourly weather data to make use of the green and amp function and simulate the effects of storm level weather events on model outputs like runoff. I'll show you how to enter this weather data so that Root Zone will be able to call it from a specific file when the model is run for a given scenario. First, let's see where you would select the right weather files when you need to let the model know to use them. Open a scenario that you have already created or that came with the model download. For example, new scenario. Here you can see where you would actually select this data within Root Zone. There are three files that Root Zone will use: the daily or hourly meteorology file, the breakpoint rainfall file, and the snowpacks dynamic file. Here you can see an example of what one of these files would actually look like. This is one of the example files that comes with Root Zone during installation, and it includes the daily data from an experiment, including minimum temperature, maximum temperature, and a couple other parameters. Snowpack dynamics files are a little bit unique. Here you can see that they don't include daily or hourly data, but rather coefficients that are used for a given location related to snow accumulation and melt. For example, albedo, solar radiation transmission coefficient, etc. To begin with, you'll need to be working with a scenario of your own that will be linked to the weather data you're inputting now. It's simplest to build one by starting with an existing scenario, like the new scenario that comes with Root Zone. Create a new one by entering a new name and optional description. Then, once you exit out of the scenario, it'll ask you to save, and you'll see it pop up under the project. There are a lot of ways to get at daily or hourly weather data. I'll be showing an example using data from the easily accessible Missouri Historical Agricultural Weather Database for a location in Missouri. Many other state universities and extension programs have similar data availability. The minimum requirements are daily minimum and maximum temperatures in Celsius and rainfall totals in millimeters, but the effect of varying storm intensities can be better modeled if hourly rainfall data is supplied. It even would be possible to supply daily temperature and hourly rainfall data. Root Zone can estimate most of the other weather parameters it uses. For example, if you have no relative humidity data, simply leave the variable as a column of zeros and it will be estimated from minimum and maximum temperature for each day. Weather data also has to be formatted to match Root Zone's requirements. For example, dates must be in what's called padded day, month, year format, where any single-digit day or month is represented with a zero before it. For example, 01 for the month of January instead of simply 1 for January. Also make sure you have all the same units and convert your data as necessary. For example, kilometers per day instead of miles per hour for wind speed. I'm working with weather data I accessed by going to the state weather database and selecting the right location and time period. Here you see the data as it came from the state database on the left, next to columns of the same data properly formatted to input to Root Zone on the right in yellow. For this database, formatting meant simply supplying the right date and hour format. This would be where you'd also want to convert anything that's in English units to metric. Once you have properly formatted the data, in the project view, go to Meteorology and then create.met/.break from the measured data. I'm dealing with hourly data for all these parameters, but the steps would be almost exactly the same if you have daily data. So, simply copy and paste your data from a spreadsheet into RootZone. The software has some built-in functions to help catch errors or discontinuities in the data. Run them by clicking this Verify button. You can see no errors are present when this box says Data Successfully Validated. For example, with hourly data, it will catch when you have unrealistic values like wind speeds higher than 4,000 kilometers per day. Or with daily data if you have a minimum temperature larger than that day's maximum temperature. With both, it will also throw an error if your dates or hours are out of order, are missing days or hours, or if you have less than 24 hours of hourly data in a given day. You can see that that observation pops up in red if any of these are the case, and then you can fix it. Once everything looks okay, click Create. Name it something that makes sense to you, but make sure to leave it in the Meteorology folder since that's where RootZone looks for the data. This step also creates the storm level breakpoint file from the hourly data that you entered. As before, once everything looks okay, click Create/Save Breakpoint File. And again, name it something that makes sense and leave it in the Meteorology folder. Now you can see that if you open one of the scenarios, our file is available to be used by that scenario. Same for the breakpoint file we just created. Saving and reopening the scenario will also update the beginning and end date to be no earlier or later than you have data for in the HMT or BRK files. And that's it. You now have weather files inputted to RootZone that will be used when you run the model. This is an important step in parameterization. We saw how to access data online, format it correctly, input it, and verify the data in RootZone, and save it as meteorology or .hmt and breakpoint or .brk files. Thanks for watching, and happy modeling.